All right, Algebra 3, Lesson 17, proofs of the Pythagorean theorem and proofs of similarity. I'm going to go through, I want to see if in the book if there's anything. There's no bolded sections, so basically we're just going to work through some proofs and make sure that you guys understand what kind of things that you want to look for when you see examples like this. Looking at question number 1, it wants us to write a two-column proof to prove that these two triangles are going to be congruent. The first thing that I want to do as I look at this is to determine which two triangles, because I don't know about you, but I see 4 triangles there. In fact, you can make more triangles out of it. You got a triangle here, 1, 2, 3, 4. That you can also make 5 and 6. Right? You can get at least 6 triangles out of that. So whenever you see something like that, you want to first determine which triangles are we trying to discuss. So it says triangle XFW. Okay, so it should be that guy right there and YFZ. Okay, so those are the two triangles that I'm trying to prove congruency for. Okay, I'm going to go ahead and write this up as statement and reason. Okay, we've talked about if we're trying to prove that two triangles are congruent. In the past, you've been given a list of congruency postulates, right? So we had things like side, angle, side, 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 angle, side, angle, 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 side, angle, 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 side. Basically, if I have two angles in a side, it really doesn't matter the combination. I just can't have one angle and two sides. Does that make sense? Okay. So some of those combinations are fairly particular. So at this point, we're going to take our given information. This could be a long list. All right. So the first thing we want to do is we want to look at the givens that they give us and go ahead and put those in our two-column proof. So WF is congruent to ZF. Okay. And let's go ahead and do XF is congruent to YF. Okay. Given. All right. Next thing I'm going to do is at this point, because we know which two triangles we're talking about.
For interruption teachers, at the end of this phone call, those teachers and students that are on the first lunch shift, they come down. We will have approximately 12 minutes till the 15. We need to get in line, get our food, get it eaten.
I'm glad we're recording this.
So after the hang up of this phone call, teachers and students are usually the first lunch shift comes to the cafeteria. Thank you.
We're number 2. Okay. Oh my gosh. Just let me. All right. So these are my givens. So let's go ahead and put these tick marks in here. We have WF to ZF. We have XF to YF. All right. We only need one more thing to make these two triangles congruent. Does anybody know what it is? Angle what? WFZ, good. WFZ is congruent to what? In fact, WFZ is not what we want. Now that I'm looking at it, WFX, very good. WFX is congruent to angle what? ZFY. ZFY. Can anybody tell me why? Don't know why. This is one of those, like, we've got the V things, vertical angles. Vertical angles are congruent. All right, so we know that to that. All right, now can I write my congruency postulate? Do I have enough information? Okay, so triangle what? Well, it's easy enough just to use the one they give me. XFW, congruent to triangle YFZ, through what? Side angle Okay, now a bunch of people have gotten in the habit of just writing SAS. Okay, and if you did that on your test, you notice that I added something for you without taking off points this time. Congruency postulate. Okay, I want to know, what are you talking about side angle side? What are you actually proving? Okay, well, we're proving that they're congruent. Okay, so do we understand? Notice that really, all I had to do was find one thing, right? That wasn't that hard. Okay, so let's do that, and let's look at our next one, number 2. Okay, put our 2-column proof up, statement, reason. Okay, can't tell it's spelled wrong if you scribble it. All right, given A is midpoint of DC. All right, so A is mid of segment DC. Angle D is congruent to angle C. Given. Okay, and you can probably should write given twice. I'm just going to write given once. All right, so A is a midpoint of DC, and angle D is congruent to angle C. All right, this next part is what we would naturally probably make an assumption about, but we're going to say that DA is congruent to CA. Can anybody tell me why? What's that? Geneva, do you know? No? DA is congruent to CA. Why? Can anybody tell me why DA is congruent to CA? There's a donut in it for you. No, I've got donuts here. If anybody knows the answer to why DA is congruent to CA, I'll give you a donut. I'm going to give you about 5 more seconds to figure it out. Why is DA congruent to CA? Based upon the information... What we're looking for is a midpoint divides a segment into, yeah, but that's kind of the point, is that you have to figure out how to say it, into 2 congruent segments. All right. So now I can say that those 2 segments are equal, right? Can anybody see what's left that we can use? Notice what it is that we are looking for, right? We're trying to prove that ED is congruent to BC. So my process, again, should be prove the triangles are congruent, then use what as my last step? CPCTC, all right? How much more do I need in order to prove that these 2 triangles are congruent? I've got an angle and a side. I either need another side or another angle. Can anybody see another angle up there that I can make? Okay, angle DA what? DAE is congruent to angle what? CAB. Okay, through what? Nope. Vertical angles are congruent. Do you see why I make such a big deal about vertical angles? Because they show up all the time. Okay, vertical angles are congruent. Now can I say that the 2 triangles are congruent? Okay, so triangle DAE. is congruent to triangle CAB through the ASA congruency postulate. Am I done? Can I stop there? No. Right? Because that's what it wanted me to prove. So I need to end with what they wanted me to prove. Okay? Segment ED is congruent to segment BC through what? Can you tell me what it stands for?
Corresponding parts of congruent triangles are.
Okay? Corresponding parts of congruent triangles are congruent. I cannot use CPCTC unless the previous statement has given me a congruency postulate. If I ever see CPCTC show up either before or without a congruency postulate, it is wrong. Enough said. Okay? Always. Not like, hey, I'm going to let it slide this time. Like, it is just flat out wrong. All right, questions up to this point? Nothing? All right. Now, here's the thing. If any of these questions are in your homework, I'm going to say this again because last time I did a proofs lesson, right, I did questions that showed up in your homework and I still had people give me nothing. You're going to get a 0 on this assignment. Okay? All right. Statement. So I would be checking the homework assignment and say, hey, Mr. Wilcox, we don't have a whole lot of time here. Could we do like questions 4 and 5 instead of question 3? Right? Those questions are on the test. Okay? I would double check. All right? Let's see. What was the homework assignment? What was listed there?
Number 8.
Looks like number 8's a proof that you'd want to see. And what number is 14 on the list? Nope, so we don't have to even do 14. Let's see. Is there anything like yeah, you're on page 131. If we get enough time, I'll actually work out number 8 with you. Okay? What? Not right now. Okay. All right, let's look at number 3. We have AC is congruent to BC. Can anybody tell me why? It's given. Okay. We have CD is perpendicular to AB. Given. Okay. So let's go ahead and put in some of this information. AC, BC. Then it says CD is perpendicular to AB. Now, that doesn't allow me to put in tick marks just yet. Okay? But we are trying to prove that these two triangles are congruent, correct? Yes. Okay. So we ought to be able to use at least one of these to find our next step, right? Particularly CD is perpendicular to AB. We've seen questions like this show up before, so we should be at least fairly familiar with being able to say that angle CDA and angle CDB are right angles. Can anybody tell me why? Right. So perpendicular lines intersect to form right angles. Okay? It's not complicated. It's stuff that you already know. We're just trying to put it into words. Okay? So, but notice we haven't said that CDA is congruent to CDB. Okay? So we want to say that. Next, angle CDA is congruent to angle CDB because right angles are congruent, correct? Yes? Okay. Now, what else do we have? I hear somebody saying something, but not loud enough for me to hear it. CD is like a reflexive axiom or something. I can't really write that up in a proof. CD is like reflexive and whatnot. There you go. CD is congruent to CD through the reflexive axiom. Good. See, there's maybe a more official way of saying it's like reflexive and stuff. Okay. All right, so that allows me to go in here and do that. Now, this is where we get into our right triangle, proofs of similarity, that type of thing, right triangle congruency, some of that stuff. We've lost the entire grade. It's gone missing. Anyway, so at this point, we have enough information to prove that these two triangles are congruent, but what I'm interested in is if you know why. Notice that they are right triangles, correct? Okay. So do we have different congruency postulates for right triangles? Okay, what can I use here? Hypotenuse leg. Good. Because AC and BC are hypotenuses, hypoteni, and CD is a leg. So hypotenuse leg congruency postulate. Okay. Questions? None? Okay. All right, I'll leave that one there because we can go on to our next page. Flip it on over. All right. You guys want to give one a shot on your own? No?
I can if you want me to.
I don't know. David's probably not doing as much showing off after his last test.
Hey. I didn't ace that test. It's the first one.
Okay. All right. Hey, let's get our stuff in here. What comes down as my first statement? To DC. Okay. This is like the most interrupted class the entire day. All right. Given BC is congruent to EC. Given. Are you guys writing this? Hopefully, I'm not the only one writing things down, right? All right. Now, this will only do so much for you if you associate it with the picture, right? So you can write down all the statements and reasons, but if you don't know, because all you're going to be given is a picture 90%, 99% of the time. So you're going to need what you see here to go with the statement and reason to be able to associate the steps. Okay, that's fine. You can do that. Yeah. I mean, they haven't released second lunch shifts, so. Okay, all right, let's pay attention. We've got AC congruent to DC. We've got BC congruent to EC, right? We want to prove that a couple of our angles are congruent to each other. Am I going to try to prove that directly, or am I going to prove triangles are congruent, then use CPCTC? The second one, right? Now, what do I need left to be able to prove that these two triangles are congruent? And what vertical angles are congruent? right? So what? ACB congruent to what? What's congruent to ACB? DCB. Good. DCB. Using what? Is it D? Oh, I'm sorry, DCE.
Using vertical.
Right? We're starting to, hopefully, the more times we use vertical angles, the more times you're going to actually see, hey, I can use that. All right, so triangle. Triangle what? Is congruent to triangle. Through what? No, we don't. Triangles are congruent using CPCTC. Side angle side. Congruency postulate. Now, is angle A congruent to angle D?
Teachers and students on the second flagship at the end of the phone call meeting.
CTC. Oh, center. I just don't.
Okay. Yes, it is CPCTC. Good job. We did almost all the questions.